Let's take a look at the balanced binary tree question from Grind75. Simply states, given a binary tree, determine if it is height balanced. First example, the whole tree has a height of 3, and it is considered height balanced. We have a 3, a 9, a 20, 15, and 7, and it returns true. Second example, not considered height balanced, and that is because the heights are not balanced, and we'll dig into that in a little bit. And then we look at the third example. If we're actually not given any nodes whatsoever, we consider that to be height balanced. The constraints are such that the number of nodes in the tree are going to be in the range of 0 to 5,000, and the value of the nodes is going to be negative a giant number to positive a giant number. Let's take a look at how we can solve this problem. So in order to solve this balanced binary tree question, we first need to know what actually is height balanced. So what that means is, from the perspective of each node in the tree, the height of the left, from its left node and its right node, can't be more than 1. So if we look at this example here that they've given us, I've drawn out the heights here. So you can see the whole tree itself has a height of 3, right? 1, 2, 3, and we've got the 3, the 9, the 20, the 15, and the 7. And 3 is the only one that's going to be on the first level. In fact, there can only ever be one node on the first level. So the height of the 3 itself is just 1 because it occupies 1. And as we go down, the 9 and the 20 have 2, so on and so forth. And so what we're asking at each individual node is we're saying, if my left height and my right height are off by more than 1, then we're not balanced. So how would we write this in terms of an algorithm? So from my left here, I actually need to recursively figure out what my left height and my right height are by visiting all of the nodes to actually get the height. I can't actually determine the height of my left and my right until I've gone ahead and done that visit. So what's going to happen with our algorithm is we're going to say to our root node, which is the 3 here, I'm going to say, all right, what's my left height? And we're going to recursively visit this 9, and this 9 is going to say, well, actually, I've got no more left and no more right, but I myself am taking up a height. So I'm going to say my height is 1, and that's going to go ding ding. Okay, my left height is 1. But in order to calculate the right here, I need to visit the 20, and the 20 is going to say, well, actually, my height is myself. If I had no children, I would just be 1. But actually, I have to check to see what my children are, and I'm going to say, all right, what's the maximum height of my left or right child, right? So I'm going to say max of left or right. That's going to be what I'm going to add to my height. And my height is always going to be 1, right? Each node itself takes up 1 in terms of height. So you're going to say, well, I'm going to visit my right, which has a height of 1, and I'm going to visit my left, which has a height of 1. And I'm going to say, all right, well, now that we've got those heights calculated, my max of left and right, 1 and 1 plus 1, my height is actually 2. And then we're going to come back here, and then we're going to say, all right, from the perspective of 1, we can finally answer the question, is the difference between the 2 and the 1 greater than 1? No, it's actually just 1, right? Which is fine for being determined if it's height balanced. But we also need to validate at each individual node to see if those nodes are height balanced. And if any of the nodes are considered not height balanced, then the whole thing is considered not height balanced. So this is going to take approximately, in the worst case, right, big O, it's going to say take a big O of n time complexity, because we have to visit each individual node in the worst case. And in terms of space complexity, same thing. We've got to visit every node. That's going to be O of n as well. All right, let's jump into the code. The first thing I'm going to do is simply unwrap my root. And remember, if we don't actually have a node that is given to us, we actually return true and not false. If we have no nodes, we are considered height balanced. And then what I need to do is think about how we're going to code this out. So we know that at any point while we're exploring the whole graph or tree, we need to keep track of at any point something was considered not to be height balanced. So I'm going to declare an outer is balanced variable, and I'm going to say that it starts off as true, and at the end I'm going to return as balanced. And then I'm going to have a function called explore, and this function is going to return an integer to return the height. And then I have to actually call the explore function at some point, and I'm going to call explore, and I'm going to say explore root, right? So in my explore function, I'm going to have a node, and I'm going to make this an unwrapped value because the tree that they give you, right, the left and the right node are considered optionals. And the first thing I'm going to do is go, okay, well, guard let node, else return, and I have to return an integer here for the height. So if I don't actually have a node when I'm exploring a node, my height is actually considered 0. Otherwise, we have to keep going with our code here. So what I need is actually my left height, as we mentioned earlier. So my left height is going to be explore, and I'm going to say node.left, and my right height, you guessed it, is going to be node.right. And then what I want to do eventually is return the maximum of my left height and my right height in terms of my children plus 1, right? Because if this node is not nil, this needs to factor in to the height math. Now, this is great, but we actually haven't touched this isBalanced variable here. Kind of a problem, right? We actually need to update that. So at each individual step, we need to determine if they're height balanced. So we're going to say if the absolute difference between the left height minus the right height is greater than 1, then the whole thing is not balanced. So we'll say is balanced false, and that should be it. So if I run this code, let's see if I made a mistake here. Looks good, and I'll go ahead and submit it. There we go. Thank you for watching this video.